In this module, we'll be looking into how web-based encryption can be cracked. So when Wi-Fi was first developed and launched in the market, security was not the major concern because during that time, every device was connected via wired interface. So when wireless interface was first launched, everything seemed magical because there was no more need of wires. So during that time, researchers had not really focused into the security part. So this was a big problem which arose a few months after web was standardized in the market because lot of people started to take advantage of no security feature in the wireless networks, and this led to a lot of bandwidth stealing, password hacking and other things. So due to all these problems, there was an attempt made to secure the wireless access points. And the very first attempt which was made in order to secure the Wi-Fi was called WEP, which stands for Wired Equivalent Privacy, and it was standardized in the year 1999. It basically also introduced encryption into the wireless networks. However, within some time, there were multiple vulnerabilities which were found based on the WEP encryption, and soon WEP encryption was hacked. Although, even though it is hacked, even in 2014, you can see there are 40 to 50% devices which are still using WEP. Well, it is dangerous, but I guess it is good for us because this is what gives us jobs, right? So let's go to the next slide and see how exactly does the cracking takes place. So the basic idea behind web cracking is to capture a lot of amounts of weak initialization vectors. So whenever the communication takes place between the client and the access point along with the data, there is initialization vector that are being sent. The more the amount of initialization vector that we are able to capture, the faster we'll be able to crack the WEP key. Now the problem is, suppose this client is connected to this access point, the easiest way, or I would say the slowest way, is to just monitor the air and just capture all the data which is flowing between the client and the access point. Obviously, this will be encrypted data and we capture as much data as possible. But in order to crack the password from the data, it will take us around 7 to 10 days worth of data capture in order to find sufficient initialization vector which is needed to crack the password. The second way is maybe to generate data packets as fast as possible, because the more the data packets that flows between the client and the access point, the more the IVs will be generated. The more the IVs that are generated, the more fast we will be able to crack the web-based network. So in the second way, which is the fast way, we use a way to generate more data packets as fast as possible so that we can generate as much IVs as possible. And the way to do is to capture a ARC based request packet. ARC based request packet generally are generated when a newly created client tries to connect to a access point. So when a client connects to the access point, it sends the ARP request, and in correspond to the ARP request, there is a ARP response which is sent from the access point to the laptop. If we are able to capture that ARP request which is been sent from the victim to the access point, then it will be very much easier for us to generate a lot of data packets, because every time a client generates a ARP request, there is always a ARP response which is generated from the access point back to the client. So suppose we capture a ARP request, we'll send the ARP request 1000 times to the access point, and access point will reply to us 1000 times as a ARP reply. So this is the basic idea behind the web cracking. So these are the overall steps for web hacking. I'll just give you a short summary about each of these steps before we start our practical session. So the very first thing that we do is we start our monitor interface. Remember, we cannot work with WLAN 0 interface for Wi-Fi hacking. So we'll have to start a new interface called mon0. And in order to do this, we use a command called airmon-ng start WLAN 0. So what it will do is it will start a new monitor mode interface. Once the monitor mode interface has been started, we scan for all the available wireless devices in our area in order to find which of them uses the WEP based encryption. So Aerodump NG Mon0 will basically search for the wireless devices in the nearby vicinity. The problem with this is it gives you a huge amount of output, specifically if you're living in a highly dense area. So what we do is once we find a particular web-based device, let's say Linksys, we lock on to that particular device. So in order to do that, we use aerodump ng hyphen hyphen bssid followed by the MAC address of the access point running web protocol. Hyphen C is the channel number. So you can see the channel number here, which is 6. It will be different for each of the web-based devices, and followed by the file where the data packets will be written. As we had discussed earlier, we'll have to write the data packets to a particular file, and we can mention the file name over here, which is myhack. This can be a dynamic name as well. So once enough data packets are been written to this file, then we can start the cracking process. So in the step 4, we try to locate if there are any ARP-based requests in the transmission. As said, ARP-based request is mandatory if you want to crack the wireless in much more faster time. So through this command, we'll basically wait and watch if there are any ARP-based requests. If Air Replay is able to capture a ARP-based request, it will take that request and it will send to the access point thousands of times. So corresponding to the 1000 time ARP request to the access point, the AP will give you a ARP reply 1000 times. So due to the ARP request and ARP reply which have been sent thousands of times between the AP and the client, there will be a lot of data packets which will be generated. The lot of data packet means lot of initialization vector, and lot of initialization vector means faster the web will be cracked. So in case a client is already connected, that means we need client to reconnect in order to generate a ARP request. So what we'll do is we'll deauthenticate the client so that the client authenticates to the access point again. And once client authenticates, we'll get the ARP request packet that we are waiting for. And once we get the ARP request packet, we'll just wait for 2 to 3 minutes and then we'll run the aircorrect command on the my-hack.cap file which we had initially mentioned. So this is all about web cracking. In next module, we'll be looking into the practical session where we'll be actually cracking the web-based router. So I hope you have learned something from this module and I would like to thank you for viewing.